Good morning and happy MLK Day. I'm Shireen Kumar and today I will demonstrate for you how the quick sort function using a middle pivot works on my random list of 19 numbers by using a stop motion video that I had made and explaining it through a presentation. So first I'm going to show you my stop motion video and it's right here. And these cups are the numbers and this arrow points to a pivot point and also the pivot value is displayed right here. The cups that are blue are the numbers being sorted and swapped. And it goes on for a little bit. It is slowed down a little bit, so it's easier to see what is going on. Okay, so breaking it down. I like to break it down into three main steps, which is first, you want to identify the pivot value and sort the numbers based on the pivot value. What I mean by that is numbers less than the pivot value are put to the left side of the pivot number, while numbers greater than the pivot value are put to the right side of the pivot number. And three, sorting those left and right sides of the pivot number. Okay, so first we're going to define the pivot. So I use this equation int p equals from plus 2 divided by 2. And this is also my list of numbers. This is the index value, and this is the numbers. So what I'm going to do is I said from, which was index number 0, plus 2, which is index number 18. So the first and the last. So they define the length and the numbers. And then I divided it by 2. So here we can do 0 plus 18, which is 18 divided by 2 is 9. So we look at the 9th index, and the value here is 60. So 60 would have been our original middle pivot. Okay, so the next step is sorting based on the pivot number. So here is a cutout video. So this is the part where they are sorting based on this pivot number. Okay, and what happens here is this while loop runs. So we're going to go back to the first. So we have 77 as I. So I is from the first value of the 0th index number. And 2 would be the last, so 51. And so is 0 less than or equal to 18? It is. So it goes to this if statement first. So is list I, so 77, less than or equal to 60? No, it's not. So it goes to the else if. And it says else if j, so 51, is greater than or equal to list p, so 60. And that is not correct. So it goes to else, and it just swaps I and j. So here, see these cups, they're swapping. So as you can see, 51 and 77 have been swapped. So that's what this while loop does. And if it does go through this, it means that a value on this side, so let's say 3, is less than 60. So it is where it's supposed to be. So it moves on to the next number, 91. So this is where it has to swap with something. And then we're here, 96. So j is greater than or equal to list p. So 60. So it doesn't change. So j minus minus goes to the next number. So that's how this while loop works. Okay, so this is the second step, which is sorting out this left part. And they sorted out when all the numbers on the right side of the pivot number is greater than the pivot value, and everything on the left side of the pivot number is less than the pivot value. So here, this is what it looks like so far. So before, our original pivot value was 60. And so all of these numbers are less than 60, and all of these numbers are greater than 60. So that's why we can start sorting and changing the pivot value. So now you can see the pivot value starts to change, and you can see that this part is being sorted out. So the sorting part, so like the switching, the sorting, everything happens with this while loop, the same while loop. So it's the same logic, everything's the same. However, we do need to switch our pivot point because if not, then we're just going to say this is the sorted list, and it isn't the sorted list. So the pivot value keeps changing because of this if statement. So what happens is the length of the list changes in courtesy of this recursive function. So here we have from and to is p minus 1. This shortens it. So this kind of makes 2, so the last number smaller. So here we have the same from, so 0, and 2 shortens maybe up till 52 or 60. So then this part would get sorted. And this if statement just relocates the pivot into its right location so that it is able to pivot. So as you can see here, the index is what changes, not the value. So you don't see any values switching because of the relocation of a pivot. It is just the index. So the pivot just changes, nothing else is swapped. The swapping part is due to the while loop. Sorting the right side is basically the same thing. So we have pivots on this side, and you can see the sorting happening due to the while loop. And again, the pivot changing is due to this if and else statement. So in the end, this is the summary of what it looks like. So I calculated the pivot, or not calculated, but found out what the pivot was for each run. So here we have the numbers first, and the pivot is 60, and then again 60. So 9 is the index number. So 9, and then 10 over here, then 9, then 4. So here we can see that the pivot's moving towards the left side to sort this part out, and then it moves to the right side to sort this part out. And this is where the numbers are changed. So you can see 71 and 77 and 51 had swapped. And then you can see 47 and 91 had swapped, and so on. And here we have our final list. So we're going to look at this once again, now that we know what's going on. So the pivot is 60 original, and they're sorting based on the pivot value. So all the numbers less than 60 are going to the left side, and greater than are going to the right side. So now we are sorting those sides. Here, the pivot value is changing due to that if and else statement, and the values are being switched with that while loop. So now it's going to the right side, doing the same thing with the while and if statements. And again, this is our final sorted list. So we have 3, 13, so on. The greatest number is 96. Thank you.